For this example, we're going to solve using the quadratic formula. X squared minus 6x plus 4 equals 0. To solve the quadratic formula, first I'm going to write down the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I have to make sure my equation is in the correct form. It is equal to 0, which is what we want, and we also want it to be in descending order. And our first thing is x squared, our first coefficient is negative 6x, and our last one is positive 4. So it's in the correct form. And then we have to figure out what a, b, and c actually are. And even though we can't see it, there is actually a 1 right there. It's not 0. So our a is 1. And then our b is this number right here, which is negative 6. And our c is the last constant, which is positive 4. Now we're going to substitute all those numbers into the equation and solve for x. So x equals our negative b, which is negative 6, plus or minus the square root of b squared, which is negative 6 squared, minus 4 times a is 1 times c is 4, all over 2 times a is 1. Now we can simplify. Here the negatives will cancel and leave us with just 1/6, plus or minus the square root. Negative 6 squared is 36, and negative 4 times 1 is negative 4, and then times 4 is negative 16, all over 2 times 1 is 2. Now we can simplify it further. 6 plus or minus the square root, and then 36 minus 16 is 20 over 2. Now, because this is 20, and we know that 20 has a perfect square in it, being 4, 20 is 4 times 5, so we can take out the 4. So we have 6 plus or minus, and then the square root of 4 is 2. And then we still have the square root of 5, because 5 is whatever's left over 2. And now we can even simplify this more, because if you notice, all of these are divisible by 2. So we can divide all of them by 2. So 6 divided by 2 is 3. 2 divided by 2 is 1, so we don't even really need to write it. And then 2 divided by 2 is 1 as well, so we don't need to write that either. So we have 3 plus or minus the square root of 5 is equal to x. So that's our final answer.